Welcome to clickmyprojects.com. Here we discuss about self-organizing map-based multispectral clustering for image segmentation. Normally, a multispectral image is one that captures image data at specific frequencies across the electromagnetic spectrum. The wavelength may be separated by filters or by the use of instruments that are sensitive to particular wavelengths, including light from frequencies beyond the visible light range, such as infrared. Spectral imaging can allow extraction of additional information the human eye fails to capture with its receptors. For red, green and blue, it was originally developed from space-based imaging. Multispectral images are the main type of images acquired by remote sensing radiometer. Dividing the spectrum into many bands, multispectral is the opposite of panchromatic, which records only the total intensity of radiation falling on each pixel. Usually, satellites have 3 or more radiometers. Each one acquires one digital image in the small band of visible spectra. In computer vision, image segmentation is the process of partitioning a digital images into multi-segmentation. The goal of segmentation is to simplify and/or change the representation of an images into something that is more meaningful and easier to analyze. Image segmentation is typically used to locate objects and boundaries in images. More precisely, image segmentation is the process of assigning a label to every pixels in an image such that pixels with the same label share certain visual characteristics. The result of image segmentation is a set of segments that collectively cover the entire image or a set of counters extracted from the image. A self-organizing map or SOM is a type of artificial neural network that is trained using unsupervised learning to produce a low-dimension discretized representation of the input space of a training space called a map. Self-organizing maps are different from other artificial neural networks in the sense that they use a neighborhood functions to preserve the topological properties of the input space. In our project, we are using the SOM segmentation to segment the satellite images, and by using fuzzy logic, we classify the classes of an images in the given satellite image. Here we classify 7 different classes in the given satellite images. This was displayed in the 7 different colors. By using SOM segmentation, we segment the given image, and by using fuzzy logic, we classify the classes in the image, and finally we label the classes by using fuzzy logic. This is the flow diagram of our project. In the first step, we initialize the remotely sensed data. Since this contains the multispectral images, the multispectral images which represents it contains more than 3 sample images. That means other than RGB color images. RGB color images represents 3 sample images, but in multispectral image it contains more than 3 samples. Then we separate each and every samples and we give as an input to the segmentation process. In the segmentation, we using SOM based segmentation. In this stage, it segments the given images into several classes. This was done by the neural networking stages. After the segmentation process was done, then we extract the feature values which are labeled in a separate labeled pixels. In this stage, it collects the label separation classes and we extract the feature values by using GLCM feature extractor. Since the GLCM feature extractor extracts the texture features for the input given image, then these texture features are extracted for each and every classes for the given satellite images. Then by using fuzzy rules, we can apply the rules for each and every classes for the satellite segmented images. The classified result it gives the class differences for the segmented output. Then finally we labels the each and every classes. Then we finally calculate the amount of labeled classes and find the accuracy by using confusion matrix. Now I am going to explain the running process of our project. Now run segmain.m file. Here I create a guide preparation for our project. Here we insert the satellite image by clicking insert button. It gets the input image from user. The image displayed in the axis which represents the input given satellite image. Here these contains different classes like trees, buildings, roads and empty grounds. Then we segment the given satellite image by clicking SEG button. It segments the input image by using SOM segmentation. Here the segmented result displays the index label separation by using SOM segmentation. Then we classify this segmented image by using fuzzy logic algorithm. For that process, we separate the each and every labeled images and by using feature extractor GLCM method, we extract the feature values for the segmented labeled images. Here we extract the feature values by clicking features button. This gives the features values for the input images. The feature values in the table gives the texture features for the input images. The texture features are dissimulation, energy, entropy and homogeneity. Then finally we classify the given image by clicking classify button. It classifies the input images and finally gives the each and every class separation by using fuzzy logic algorithm. Here the figure displays the classified labels and it collects the amounts of informations for the each and every classes. Then by using confusion matrix we find the accuracy of detected class labels by using SOM and fuzzy logic. Thus we segment the given image and finally we classify the images for the classes by using SOM segmentation and fuzzy logic based classification. Thank you.